Welcome to Chapter 8. Chapter 8 is all about something we call parametric equations. So let's start by introducing what those are. Now, as we've seen most recently in section 6.2 when we graphed polar coordinate curves, there are a lot of graphs out there that are not functions, meaning they don't pass the vertical line test. However, parametric equations allows us to think of these weird looking graphs as functions. Here's the idea behind it. Let's imagine that we have a bug that is crawling across a table point. The bug starts right here at point 0, and then this is the path that our bug is crawling. Now, the path that the bug crawls is not a function, does not pass the vertical line test. However, we could instead think of the bug as being only at one point at one time. So we could define the bug's x-coordinate in terms of what time he's at that coordinate, and the y-coordinate in terms of what time he's at the y-coordinate. That would give us two functions. We could call it f of t for the x-coordinate and g of t for the y-coordinate. And those would be functions because the bug is only at one place at one time. Bug can't be two places at a single time period. So we instead define this curve in terms of where the point is at what time in terms of t, and then we graph it. And now we can think of it as a combination of two different functions. So t is called our parameter. And when we have x is the f of t, y is the g of t, so we're defining the x variable and the y variable, we call that a system of parametric equations. So let's try and graph our first one. Here's how we're going to do this. All we're going to do is create a big t table, where this first column is going to be all our x coordinates, and this second column is going to be all our y coordinates. And I should have said second and third, oops. And the first column is our time. Now this problem says I want t to be greater than or equal to -2. So I'm going to start my numbers at -2 and work my way up. Now all I need to do is plug these times into these individual equations. So the first one, I get -2 squared minus 3 is 1. -1 squared minus 3 is -2. 0 squared minus 3 is -3. 1 squared minus 3 is -2. 2 squared minus 3 is 1. And 3 squared minus 3 is 6. Then I come over and do my y column. 2 times -2 minus 1 is -5. 2 times -1 minus 1 is -3. 2 times 0 minus 1 is -1. 2 times 1 minus 1 is 1. 2 times 2 minus 1 is 3. And 2 times 3 minus 1 is 5. Now I'm going to graph these as x comma y points. So my first point is going to be 1 comma -5. 1 comma 1, 2, 3, 4, 5. Then I'm going to have -2 comma -3, -3 comma -1, -2 comma 1, 1 comma 3, and 6 comma 5. And I'm going to start at my starting t point and keep going. Now, one thing that's unique to a parametric curve is you need to make sure to draw arrows to show what direction the curve is going. So we're showing that we're starting here, that's our first t value, our first point, and then I'm going this way of following my parameter t. So if you don't have those arrows on that graph, you will be marked wrong for that. So be really careful about that. So starting point, and then the arrows show us what direction to go. And that's graphing a parametric equation. That's all there is to it. So let's have you try this next one. Make our t-table. X is t cubed this time, y is 2t squared. My t-values only need to go from -1 to 1. So I'm going to include a point in the middle there just to give me a little more detail. 3 points isn't a whole lot of detail to see what's going on here. So we'll do a point in the middle. You can do multiple points in the middle if you'd like, whatever you want. So what I'd like you to do is pause the video, plug these into my equations, graph them here, see what it looks like, and don't forget to draw your arrows. As you check your work, you'll notice first that I changed the scale of my graph to zoom in on this a little bit. I made every 2 boxes 1. Just that way, because we're working with pretty small fractions here, it's a lot easier to graph it and see the shape that I'm looking at. So I started here at this point, -1, 2, came down to the origin, and then came back up to 1, 2. And you'll notice that I included my arrows to show the direction I'm going. And that's it. Let's try the next one. So we got t is greater than or equal to 0. So we make our t-table. We're going to start this at 0. And we have x equals 2e to the -t, y equals e to the -2t. Just plug those into your calculator, fill in your t-table, graph them. I'll warn you right now, you probably also want to scale this one in like a lot. I would highly suggest this scaling. So this is all 1, and then this is 1, 2. And then get all these points and graph them from there to see what this looks like. Don't forget your arrows, and then come back and check your work when you're ready. Check your work. We started over here at 2, 1, and then these answers are getting closer and closer to 0, but you'll notice that because it's an exponential, they're never actually going to reach 0. These are going to get way closer, but they'll never reach it. So that's why I have here at 0, 0 at the origin an open circle, showing that these answers are going to get closer and closer to this origin point of 0, 0, but never actually touch it. And then, of course, I added my arrows in to show direction. Okay, let's try example 4. This one, oh, hey, look, we're getting back into some trig stuff. And I want my t-values to go from 0 to pi. Now, this one's a little tricky because be careful here. Notice I am not including 0 and I am not including pi. I want to go from 0 to pi, but don't include those points. So what I'm going to do is just pick the points off of the unit circle between 0 and pi. So that gives me these ones. So what I'm going to do, take all these points, plug them into these 2 equations. Remember, cosecant of t is the same as 1 over sine of t. That should allow you to put it in your calculator. Then you're going to graph all of these as x, y points right here. Once again, I would highly suggest you zoom in on your graph. You're going to get some small decimals this time, like that. So pause the video, plug these all in to work through it on your own, graph them, come back to see what you get. Okay, so here's the points I got for my t-table. I graphed them all. So I started right here at this point. I came down to 1, 1. Then I flipped direction and went back up. Now, notice that I included an arrow on the end of this because remember, we're getting closer and closer to pi, but not including it. So 5 pi 6 is not actually my last point. I could keep getting closer to pi by doing 7 pi 8s, 8 pi 9s, 9 pi 10s, 10 pi 11s, and keep plugging those in to get closer and closer to pi. So these answers will keep going forever and ever. They're going to reach this asymptote that they're getting closer and closer to that pi value. You'll also notice that my arrows go both directions because I start going this way, then I flipped and went back that way. So my arrows go both ways. That one's probably the hardest one from today. Our last one is a lot easier than that. So very last problem of the day. This one we want to go from 0 to 3 pi halves, and notice I want to include those. Now I'm not going to include all the unit circle points because I don't really need to, so I'm just going to include the pi fourths and pi halves points. So those are my points. Plug those all into your calculator, graph them, and then don't forget your arrows, and then come back to check your work, and then we'll be finished. Check your work on this last problem. Here's all my points, and I graphed them, and I got this. Notice I have my starting point here, and then my arrows to my ending point. Hopefully, you'll recognize this from your 1050 days as a portion of an ellipse. Back to conic sections, I know, and specifically it's 3/4 of the ellipse, 3/4 of the way around. That's not a coincidence because 0 to 3 pi halves is 3/4 of the unit circle radians. So that's why we see 3/4 of it there. So that is it for this whole lesson. Anytime you're graphing a parametric equations, just make a t-table, make both of your columns x and y, and then plot the points to see what shape you get. And that's it for 8.1.